Hello, everybody. We're running a little behind schedule, but I hope you'll bear with me. I'm coming from San Francisco, and there aren't too many people here coming from America. In the last 3 years, our travel options have been severely curtailed, as has our ability to play music together on the net has been, or just together. When was the last time you were in a room with your friends and playing music? And we've learned a lot in the last few years watching religious services on Zoom and music lessons and link ups about how important it really is to play music with each other and for each other. And I believe that the web technologies are not maybe so sophisticated as the kinds of stuff we've been discussing the last 2 days and we'll be discussing tomorrow, all of which are fantastic and incredible. There's still this need for people to gather and play music together, as we say, the live performance experience. And the web audio and just the web in general gives us this ability with some constraints. And my experiences using some of the available technologies over the last couple of years, along with my colleagues here, led me and us to develop this system called Telejam, which attempts to defeat some of those constraints in a pretty unusual way, but it works musically. We've been discussing and thinking about this kind of thing, in the recent time, but it's incredible to note that 60 years ago, the video artist Namjoon Paik, who was trained as a classical pianist, proposed this sort of experiment. Two pianists, one in San Francisco, one in Shanghai, playing the left and right hands from a Bach piece in synchronization via radio broadcast across the so-called Pacific Ocean. And may it be so. 60 years ago. And when I read this, I realized that's interesting because just about a year ago, when I encountered this, I had done pretty much the same thing between here and Bangalore, between here and Hawaii, Brooklyn, Baltimore, South Korea, Tel Aviv. It is possible for musicians to play in synchrony together across the net with each other and for each other in real time. Now, this is something that has been traditionally thought of being limited by distance. Systems like Jam-Kazam, Jacktrip, Soundtrip, Jamulus. Bands have started to use these systems with some success within constrained environments, 500 miles, maybe 1,000 miles. But how about 9,000 miles, 14,000 miles? It is possible to do, and thanks to simple APIs like WebRTC and Web Audio, which is why I'm here. When friends said there's this conference and they want collaborative apps, novel apps that are using these technologies, it hit me right. It's like we're using these straight out of the box, nothing special, no WASM, no extra plugins. It's amazing what this technology can do with a little bit of hacking. So here's the problem with traditional architectures: 3 players playing, connected either hub and spoke or peer-to-peer. No matter how much you try to squeeze the time of flight latency between those players, it's going to be a little jittery and a little different between each player. And you're going to have scaling problems. For sure, in the first case on the left where you're peer-to-peer, the time of flight from A to B will be different from B to C and different from C to A. And as you add more and more players, you're going to scale up the CPU requirements on each one of those client nodes. So more problems. And of course, in hub and spoke, there's one peer-to-peer connection through a server, so a little less problem there. But the jitter between players, or the synchronization, depending on which you want to look at it, will still be rather loose. And as those arcs get longer and longer and longer and longer, ultimately failure. No matter how you've coded this and how clever your algorithms are, you're going to be killed by the latency effects. So we came up with this. This is a different architecture. I call it Sigma streaming, and it's pretty darn simple. You start with the first player who hears nothing. They're basically laying down the backing track. They transmit their audio via WebRTC to a peer. Doesn't matter how far away they are because the peer hears the music, totally unaware of the latency. The peer basically does an overdub in real time with the audio coming in from the present node. That's mixed together and then sent, again, via WebRTC to the next node where they hear perfectly synchronized. This is why I call it zero latency. In their ears, 2 tracks. They overdub on that. Now you've got 3 tracks, and so on, and so on, and so on. Spits out the end, and this can either be broadcast immediately to a live audience that's participating and listening. And we have done this usually in the context of religious services to establish a choir that is participating and singing through the service. And I've done this with choirs distributed all across the U.S. San Diego, Baltimore, San Francisco basically is my most often used test case. So in this case, we are able to generate music that is sort of like the old music -1 records that we had in the old days where you'd play a record and you'd practice along with it. But this is not MMO, it's OMM, one more musician. As you go down the line, you get another player, another player, another player. So the experience to each player down the line gets richer and richer. And there is this opportunity to interact, because if A starts playing faster, B will probably go faster, softer, louder, and so on down the line. So you get a feeling of participation. It's not exactly the same as what's going on in real life in a room where it's all against all, but this is not a musical. Because think of the way we've been creating recordings for the last few decades. It's called an overdub session. Quite often someone will go into the studio, there'll be a backing track, which could have been recorded weeks ago, a year ago. It could have been it could be an archival track, and you're playing with your father. Things like this have been done, and you can record over it. Then get sent on to the next person. Tracks are added. This is live multi-tracking. Is another way to think about it. And again, if you're laying down the track, if you're playing it, Wayne Shorter used to say, "What does jazz mean? All it means is I dare you." So even the first player, who's not getting the feedback, can have that kind of little bit. I wonder what they're going to do when I lay this chord in. Bam. And then so on down the line. And then you'll see how that works out in a moment. So there's Sigma streaming. Here's the implementation. And it's pretty obvious and it's pretty simple. WebRTC node to node, web audio within the node to do all the audio routing. And basically the audio routing here is monitoring what's coming through the left into your headphone, mixing what you're playing along with, and then sending it on to the next person. Very, very simple to implement. In fact, when I started working on this with Boris, I think we had something up and running in a matter of 2 months. And the initial prototype was actually working on long distances immediately. There was really not much to be done here. So Viva Web Audio and WebRTC. Now, as we learned with the simple architecture, though, there were other things we could bring to the table that made the experience even more enjoyable and pleasurable, and they came from common practice in the recording industry. It's things that we do already, but you don't see them built in to these kinds of platforms because everybody's excited about compressing their latency and measuring ping time and jitter and buffer size, but give the user some sort of an interface that makes the entire process very simple, very clean, and very non-technical. The first step here, of course, is this is web audio. If you try to run programs like Jamulus or Jacktrip, you're going to have to install. You're going to have to get through ASIO drivers if you're unfortunate to be running on PCs. You read the literature and they say, oh, you have to have a wired internet connection. Oh, you have to have good headphones. Oh, you have to have a big computer that's powerful. We've been running this on the Chrome web browser now with hotspots, with PCs, with Macintoshes, with Bluetooth headsets, with outboard USB commercial microphones that have huge buffers, and it all just works and synchronizes the players. All they need to do is hit a web URL and start playing. But there's a couple more tricks we needed to add to make that work so fluently. We were shocked to discover when we started having players participate with out-of-the-box PCs with their usually built-in sound cards that had large buffers, that when we did the mix, we were getting a pretty much predictable 122nd millisecond delay when that mix happened. And that was all within the machine itself. Nothing contributed by web audio or WebRTC. So the fix, as you see in a lot of web DAWs these days and high-performance audio interfaces, was to defeat the round-trip latency by adding a delay line here. So this was kind of clever and kind of fun to say that to defeat the latency, we added latency by putting this delay line in. But of course, this is all transparent to the player. They're monitoring what's coming in They're hearing it, they're playing it. They don't have to monitor the mix. In fact, you don't want to monitor the mix because of that delay. And it just gets passed on down the line. Pretty simple. So that was fun. Now, what's going to happen, though, at the end? How come, everyone can't hear everyone else? Well, let's do the two-way talk mode first. So this is one way. And usually when we started this, we'd have a Zoom conversation so I could get people set up, and I'd put in the chat window and say, here's the URL, let's please hit it, let's play. And we'd go back to Zoom to talk about it. But, WebRTC is two-way. What's the problem here? There actually isn't a problem as long as you're not interested in synchronization in the opposite direction. So we just did the full duplex communication link, did the mixes as correctly as we wanted to do, and now all of a sudden, when you're not trying to play in synchrony, people can talk with each other. And another interesting bonus from this is when we ran Telejam, used to be called Jam RTC, against Zoom with the Zoom audio turned off, all of a sudden the people on the chain could speak with each other without active speaker cancellation, which is what Zoom does to you all the time, right? If there's more than two people on the line, somebody coughs, all of a sudden your mic is muted and Zoom thinks the other person is speaking. And this was incredible. You get the experience as if you're sitting around the dinner table with your friends and you're all just chatting away, irrespective of the distance between each other. So there's the two-way talk mode. We can run this chain in unidirectionally for playing in synchronization, or in two-way talk mode in order to discuss what we're going to do next before we go into the play mode again. Then, what do we do about listening to the final product? Well, we built a recorder into every node. And usually, in the first case, the recorder would be in the last node because obviously that's the final performance that you want to hear. And then we want to bring that back to the A node, play it back through everybody so we can discuss immediately. This is like reviewing a take in a recording session. So this is the normal workflow that we do when we're using Telejam. We discuss what we want to do in two-way mode. We go into play mode and synchronize. We play together, and we immediately, we're calling it now instant replay. And it's, you're sitting there with the board and you're listening. You can discuss, you can chuckle, you can see, how did you respond to the strange little ending that I slipped in there as a challenge to folks. And again, the recording serves as an archive, and we've saved all of these. So I've documented, the progression of the kinds of performances we've done. But another interesting bonus here is that the recording is embedded in every client node, which means not only can we record the mix at every node, which I used to debug in the early days, it's more useful to record the individual contribution of each player as a lossless WAV file. And now we can throw those up into the cloud, pull them back down again. Something's happening in Zoom here. Is it security? I can just click that away. Okay. Oh, click it away this way. Okay. I said the wrong word. I said Zoom. Oh, it's listening to me. Too intelligent. What should I say? Let's just put the window aside. I don't think it's going to let me do it, but maybe it'll stop. It persists. Okay, so we have the ability now to simultaneously record the synchronized performance and the stem tracks, which can then be downloaded into a DAW. And hey, what if it's one of our wonderful new online DAWs that we have now? And you can ping pong back and forth. You can have all your talent there. You can have the collaborative mixing console there. It's not even going to let me click it away. And you can iterate back and forth in a production mode, all available. So the sum sometimes is greater than the whole of the parts. Finally, we do have the ability to loop back. So it could be the case that the leader in A is not actually participating with live music, but might be playing a pre-recorded backing track or metronomic track, or generative music, actually, if they want to feed it in, and running down the line. And rather than be in two places at once, which was my original design, which the leader could occupy the A position and the C position and be monitoring back and forth, which makes you a little bit crazy with your mixing routing. We actually close the loop, bring it back, but do not send it back down the line again. So the leader can be monitoring the entire performance as it goes on, as long as they don't want to participate live. Otherwise, there the latency will be apparent. But this is very useful because, again, to make things simple, who's going to be adjusting the levels of the players? Initially, we ask the players themselves to adjust their levels. And in fact, if you look at Jam, Kazam, or Jack Trip or Jamulus, every player has their own little mixing console. But that's not what you want to do in a recording session. And that's not what you want to do in a casual, musical jam. You want people to gather, play, and have fun. But somebody should be in charge of those levels to keep things working. And that's what we call the leader, the first person in the position. And via signaling to all the nodes, the leader can adjust those input levels as the performance progresses. Of course, there is a little bit of latency there, so you're not going to get immediate control, which is another reason why we would rehearse for a little bit to get a flavor for what kind of levels we want on the different players. There's also this challenge here about in what order should the players be playing. But that's malleable. The leader can actually stop the chain, rearrange the players, and go again. So depending on the context and the type of music you're playing, if it's improvisatory, it can be a little bit more open. You can have your rhythm section at the front, your soloists down the end. If you're playing written music and you're looking at the score, you can determine which is the part that has the greatest amount of rhythmic compulsion. We'll put that at the front and then go down the line. If you're working with a choir, you might want to put your three most solid singers at the beginning, and then the rest of the choir can work in intonation with them. In fact, programs like Jamulus initially got a lot of pickup in the US with choirs. And there's a couple of reasons for that. I think one is that you don't need really exact synchronization with a choir. It's slow onset, and they love to turn their reverb up, which kind of blurred all of that stuff over. But when you're playing, which I do a lot with more jazz players, with quick onsets and faster tempi, you want to be able to make sure that everything is in synchrony. And Telejam does this. So we have the loopback to close that. So what's the idea behind making it easy for people to use? And this is where a lot of time was spent, working on the UI. The UI is not beautiful, but the UI is minimal. And that was my choice here. I'm not a web designer. So when the user, any anonymous player, gets the URL, they're basically asked to type in their name and join the session. That's it. Easier than Zoom. And this is what they see. Of course, there's a chat channel there in case the WebRTC goes down, but we rarely use it. The chat channel is actually there for system information, just for general monitoring. You can see the modes. They're either in play mode, talk mode, and stop or mute or special modes when audio is not flowing. The mode is controlled by the first player, not by this anonymous player here, who happens to be Mike, who's in position 2. You can see the chain. He's in position 2. He can select his input device and his output device. And what you see there for sliders are the monitors in your headphones. They don't determine anything about your contribution to the mix, but if you're playing with a flute, you really don't have to monitor what you're playing in the flute because you're going to hear that in the room. But if you're playing an electronic instrument like a keyboard or a bass, guitar, whatever, you're going to want to have direct monitoring. So we have that capability. And the meters are showing you actually what is flowing down the chain. The meters are not metering what's in your head. You can hear what's in your head, but you just use your sliders. But the meters are a way to show that, oh, your input might be a little bit too hot. But again, it's the leader up front that's going to be adjusting that. But for the case that, of course, it's a computer and you've plugged your computer into what interface you've got, it may have a pot there as well. So the leader may say, you are really too hot. Turn down your interface input and let me decide how loud you should be. And so that's the metering there. There's really not much else going on that the user can do, the player. They'll see the recording light go on when it's recording. It'll go off. They'll see the mode change mostly from play to talk. They can sign out if they want to leave the session. The yo button was there for when things go wrong. Things do go wrong, but very rarely it's been our experience. The connections between players for the audio are WebRTC, but the signaling is going on via shared Firebase real-time database. And strangely enough, over time, we've seen more problems with connections to Firebase than peer-to-peer connections with WebRTC. And I haven't been able to get an answer out of the Firebase folks why that should be the case. It seems to have some sort of a timeout even if you're not using it. But we can recover from that. But if for some reason player down the line, a string broke, and the leader can't hear it because they're not monitoring, and the player doesn't want to type in chat, they can hit the yo button, which will send an audio signal back to the leader that actually goes quack quack. I just like to do that. Catches your attention, and the leader can then decide what they want to do. They want to just keep on playing or stop and reset. So what does the leader interface look like? Not much different, but now the buttons are active. The leader can record, and the recording can be in two modes. You can record just the endpoint performance. If you want to record the tracks, you can do that. Once the tracks are recorded, when you stop, the last take is immediately available to be replayed. That's what the replay button is there for. There's a slate button there that actually, how do we synchronize the stems? Because there's no time code flowing through the system. This is done completely with just stone cold audio passed from player to player. So we do the old-fashioned slate. We send 8 ticks down the line, and when you get those stems back, you will see those 8 ticks, and that's how you will resynchronize the stems in your digital audio workstation. It's very quick. It's very simple. Then we've got the buttons for play, talk, and mute. And again, you can see the chain down there, and now I mark at node number 1. The underline means I'm a leader, and the bold means that's my node. Again, at the upper right, you can see input and output device. And here I have some extra inputs by virtue of being the leader. I can put in an auxiliary input like a sound file, and I can play it back to the group, and I can change the input level of that sound file. And again, there's my my local input level. Since I'm the leader, nobody else is going to set my input level. I have to have a slider there for that. And below there is my input monitor and my remote monitor for what I'm playing and for what's coming from the left or from the loop back, depending which position I'm in. And finally, adjust Boris. This is the slider that allows me to select one at a time any one of the players, and I can view the meter of their input on my machine and adjust it. So I can look at the remote monitor, which is the total mix, and the adjust monitor there, which is the metering of the player that I've selected, and be the man behind the curtain that's running all of that kind of stuff. One other trick that we've done here is that we've used RTC in stereo mode to have a ghost or gifted track that runs down the line, which the leader determines the content of that track. So say you've got a choir and you've got a piano player playing for your choir and everybody's coming in and singing. The mix is going on the left channel. The piano is going down the right channel. At the end, you can remove the right channel, and you've got an a cappella performance for free. You can do the same thing if you want to be as old school as a click track, which we normally don't do, but I've done demos with people that really want to hear a click track to see if they really are in sync, and they are, but then you can throw the click track away at the end. Or you can keep it, put it in your DAW and play games with it. So the idea here, is player interface, just pick up your instrument and play, please. Leader interface has to learn a little bit more. And the leader runs the session. And this is what happens when you've got conferencing systems. You don't go into a Zoom call without a host, right? You don't go into a recording session without a producer who's running the show. And that makes the thing so much easier for the players. And it's been my experience that I'm not working with computer music folks when I'm using Telejam. I'm working with naive singers. I'm working with music students across the world. I'm working with professional groups that really don't know anything about the technology. They come in, they expect their producers to do the work with them. And we're doing this just about every week, and I've been doing it for about 2 years, and with every continent pretty much except Australia. I have not been able to scale up much past 7 or 8 players because I haven't been able to find people who can work with me who are awake at the same time that I am. So we've conquered distance, but it's still hard to conquer time when the player in Bangalore is 14 hours ahead of me. But we do it. We do it. So what we've learned by Telejam, this is a group here where the 2 singers, the ukulele player and his wife, the singer, are in Hawaii. The keyboard player is in Oahu, the bass player is in Brooklyn, and I'm over there in San Francisco having a good time. But what we've learned with this architecture is that distance is no obstacle to playing together in tight synchrony, because all of the other platforms for jamming, they all throw up their hands like, sorry, impossible. You just can't do it after X thousand miles. Not true. Not true. The one-way audio channel does not necessarily prevent a satisfying musical interaction. There are some players that will just say, no, I can't do that. But those are also going to be the same players that will refuse to do an overdubbing session, probably. It's not for everybody, but we've achieved a lot of success with a lot of different people coming from different backgrounds. The web-based implementation is magnificent. It provides such a low bar to participation, and the audio quality, thank you, is wonderful. The Opus encoder is running at 48K. It's fantastic, and it works just fine. And then for the digital audio workstations, you've got the lossless stems when you want to resynchronize and reproduce for another application. So there are many, many kinds of online musical experiences. When you think about the necessary coordination that you need for an ensemble, I like to compare what you have with an orchestra, where the context is fixed. Those notes aren't going to change. They're on the paper in front of you. And there's one conductor up there who's basically going to be leading the show. Everybody else must follow the conductor. We don't obviously have video here, but each player is hearing more and more of what's going on and having the score in front of them. They're doing score following, obviously, so it tends to hold things together. You go more towards a string quartet, this could be more difficult, and I'm trying to find more string quartets to work with, and it's going to be very context dependent on the literature they're playing, I believe, and or use a conducting track or a click track of some sort, because the lead changes from player to player in that sort of situation, and that may be the less commodious use case, but we're still looking to experiment with that. I'm quite eager to try it. So having the leader and the recording playback feature helps. Other kinds of musical experiences are less context dependent, like jazz and improvisation, in which case you have to understand who's in what order. But the main thing is to be able to plays the thing. And when I hook people up on Telejam, especially over these last 2-3 years, and they're laughing and they're crying, we haven't been able to sing, we haven't been able to play together in so long, this is magnificent. There is a place for this kind of musical interaction on the web with these kinds of tools. You can see a little bit more about Telejam on telejam.net. There's some musical examples there. You can always contact me. That's my email, fetch@att.net, and I'm happy to take questions.
Thank you, Mark. I guess there is time for a very quick question. We really
and I can hang around afterwards.
Yeah,
too,
but there is a coffee break, so you can also. So is there any burning question? Like not thinking about the coffee now? No? So maybe you can then follow up during the coffee break with Mark. Thanks again.
Sure.